we begin with the thymus, one of the primary lymphoid organs. Alright? And this is our thymus here, my beloved. This is the thymus. Alright, so in front of the thymus, there was supposed to be what? The sternum somewhere here, whilst posterior to it is the what? Is the aorta. So our thymus, friend, actually it is lying in the mediastinum. It is in the mediastinum, alright? And it is found in the superior and inferior mediastinum. And in the inferior mediastinum, it is specifically in the anterior mediastinum. So this is the kind of a structure that we are considering, the thymus. So we have to know that the thymus now, it is a lymphoepithelial organ. Referring to the lymphocytes, epithelial referring to the epithelial primordium. So it has the epithelial primordium and as well as lymphocytes as part of it, as what makes it up. Alright, now it is so interesting again to remember that the lympho part has its own origin. It has a different origin, while the epithelial part, the epithelial primordium, also has got its own origin. Then the two come and make a single organ that we call the thymus. Wow. Because of that, therefore, our thymus has dual origin. Exactly. Because the lymphocytes, we said, which make up the lympho part, they are coming, or they arise from the what? From the bone marrow. Wow, the epithelial primordium comes from the third pair of the pharyngeal pouches. So in summary, we are saying our thymus has dual origin, that is the bone marrow and the third pair of the pharyngeal pouches. As we said before, it is found in the what? In the mediastinum. So let us look at the structure now of this thymus. As you saw it in that diagram, that thymus, friends, it is covered by a vascularized capsule. This is the capsule here, friend. This is a histological view of our thymus. And it is found to have a capsule. A capsule is just a connective tissue. And this connective tissue that is covering our thymus, it is said to be vascularized. It is a vascularized capsule or connective tissue. And as you see here, beloved, that this capsule, comrade, this capsule, see, it is extending. Some parts of it are extending into the inside. These extensions of the capsule, friend, we call them trabeculae. These are trabeculae. And when you look at these trabeculae, they go in, but they are now cutting our inside. The inside of the thymus is being cut or divided into some parts. I see there is this part, there is that part, there is that part, there is that part, and this part and that part there. These portions divided by the trabeculae, we call them lobules. These are the lobules. So in other ways, our capsule or this connective tissue covering is extending trabeculae inwards to cut our thymus into what? Into lobules. And these lobules are incomplete. As you can see, this is not really complete. You can't see where it is ending. Okay, it is continuous with these others. All right, so they are incomplete what? Lobules. Wow. So let us now focus on a single lobule. We see what really makes up a lobule. So when you look in this diagram, beloved, you'd find that a lobule has got two parts. It has the central part, this central part which is lightly stained. And it has got the peripheral part which is darkly stained. So our lobule has the lightly stained part which is the center, and we call it the medulla. It has got the peripheral part which is darkly stained, that we call the what? The cortex. So let us look into details about the cortex and the medulla. Now, the cortex, let us begin with the cortex. The cortex is darkly stained as we saw it exactly, and it has a lot of immature T cells. There are a lot of immature T cells. Remember those T cells, immature ones that were produced by the bone marrow. They had to migrate to come to who? To the thymus, where they will mature from. So in the cortex, we are finding what? Immature T cells. Also, in the cortex, we are finding epithelial reticular cells. There are epithelial cells and also dendritic cells and macrophages. The mature T cells will mature in the cortex. So the T cells matures from where? In the cortex of the thymus. The dendritic cells assist in the maturity of the T cells. Even the epithelial cells also help. Alright, they assist in the maturity of the T cells by secreting thymic hormones. So this diagram is trying now to show us how things are in our cortex. We are having the lymphocytes, which are the T cells, alright? T cells that are immature, and now they'll mature from our cortex, and even in there we are having these spaced epithelial reticular cells. Alright, and in there we have dendritic cells and even macrophages. So that is our cortex. What about the medulla? The medulla is lightly stained as we saw it exactly, and now this one has got large mature T cells. It has got also the dendritic cells, it has epithelial cells and macrophages. So those T cells which are maturing in the cortex, they'll get to be deposited into the medulla. Now, some epithelial cells in the medulla, they'll arrange themselves, they'll come to make a group, what we may call a concentric layer, all right? And they become flat cells, and they degenerate and become filled with keratohyalin granules and the keratin filaments. So they have much of keratin filaments. I'm saying of these, some of the epithelial cells that will come together in the medulla there, some of the epithelial cells come together to group themselves and become flat cells, and they degenerate and become to have much of keratohyalin granules and much of keratin filaments. Now, this group of these epithelial cells, we call this cluster, we call it the thymic or the Hassall's corpuscle. The thymic corpuscle or Hassall's corpuscle. All right. So what we are talking of here is this. Right in the medulla, this this group of those epithelial cells is what we call the thymic or the Hassall's corpuscle. The function of the Hassall's corpuscle is to secrete cytokines that will regulate the activities of local dendritic cells, all right, and also to secrete factors that will promote the development of T cell, of the T regulatory cells for peripheral tolerance. So this is our medulla. Okay, now how is our thymus supplied with blood? All right, so our thymus has arteries in itself and even veins, and they are surrounded, those veins and arteries in the thymus, they are surrounded by the epithelial reticular cells. All right, now the capillaries of the thymus, one interesting feature of them is that they are not fenestrated. That is, they do not have gaps. All right, they do not have gaps. They are not fenestrated. If it will just be continuous like this. It will never have gaps. It will never have gaps like here and here and here. Okay, it will never have windows. This is what we are saying. It will never have windows like these windows here that we are seeing, these windows here. It will never have windows. It is they are non-fenestrated. And because they are non-fenestrated, they also have a thick basal lamina where their endothelial cells lie. All right, the basal lamina is so thick, and that is creating what we call the thymic blood barrier. And because of this barrier, the proteins, they are impermeable, and even the antigens can't pass into the cortex. The thymus also is supplied with blood with blood, all right, by the branches of the internal thoracic artery. So what supplies, what brings blood to our thymus here, this thymus, okay? We are seeing this artery here and this artery here. These two arteries are the internal thoracic artery. So we have the internal thoracic artery. So we have the right one and we have the left one. So the branches, now branches from these thoracic arteries, they bring blood to what? To our thymus. So branches of the internal thoracic arteries, they do provide blood there. Branches from the inferior thyroid artery. The inferior thyroid artery as well supplies blood to our thymus. Also sometimes from the superior thyroid artery. Those are the arteries that supply blood to our thymus. How is now the blood from there drained? Some thymic veins, they usually merge medially to form a common trunk that opens in the left brachiocephalic vein. We have the left brachiocephalic vein. So what we are saying here is that blood from the thymus will be drained in the brachiocephalic vein. How? Some of the thymic veins, they will emerge, they will become one, all right, form a common trunk that will empty the blood into the brachiocephalic vein. And also some of the thymic veins, they drain also in the internal thoracic veins and the inferior thyroid veins. So internal thoracic veins, inferior thyroid veins, and the brachiocephalic veins, those are the veins in which the blood from the thymus is drained into. Also sometimes it drains directly into the superior vena cava. All right, now how is the lymphatic drainage? The thymus has no afferent lymphatic vessels. Wow, this is very important. There has no afferent lymphatic vessels. So meaning it doesn't receive lymph from other organs. Very important. It has efferent lymphatic vessels that arise from the medulla and corticomedullary junctions. Okay? It drains through extravascular spaces and drains into how we are talking of how now the lymph is being drained, and it is drained into the brachiocephalic nodes, into the trachobrachial nodes, and into the parasternal nodes. Okay? Its function, what are the functions of our thymus? Well, it induces central tolerance. It induces central tolerance. What we are saying there is that central tolerance has to do with, if there are those cells that are immunocompetent, which can't differentiate between self and non-self, they will be destroyed. That is central tolerance. Okay, it is also a site where T cells mature. Exactly, it is fully functional and it is formed at birth. It is fully functional and formed at birth. It remains large and functional, and it attains its greatest peak size at puberty. It becomes very large. Okay, at birth it is fully functional and it is fully formed. Okay, now at puberty it attains its greatest peak size. Okay, and it remains large and functional. But after puberty, then it will start to involute, that is to shrink, to reduce in size, and that will affect also its production of T cells. So there will be a reduction in the T cell output. All right, endocrine function. This our thymus, it secretes the following hormones. It will secrete thymosin, thymopoietin, thymolene, and the thymus has and thymus humoral factors. Very important things to note. So this is our thymus. All right, that is our thymus, its endocrine functions, and its drainage system and its structure. This is what we need to know about our thymus. So join us as we will now look at this structure, this other lymphoid organ. So join us in the next video.